Question 7 is a combination of volume problem and a nets problem. It's got the potential to be quite complicated, but this one is relatively straightforward if you process it logically. So this diagram drawn on a centimetre grid, that's important. Centimetre grid is an accurate net of a triangular prism. Now, triangular prism, we need to know what the word prism is. Prism is a 3D shape with a uniform cross-section. And that means if we were to slice it like a loaf of bread, we'd have the same shape going all the way through. The fact it's a triangular prism means that the shape going all the way through is a triangle. So it would be like a Toblerone bar. Now they want you to work out the volume of the prism. First thing I'm going to point out on this though is that they want to find the volume, and straight away I've trained myself to always look at the answer line, because this answer line is missing units. So straight away, by knowing I'm working with volume, which is measured in centimetres cubed, I know I will get 1 mark just for having that there, regardless of how I calculate my answers. So in order to find the volume of a prism, you first of all need to find the area of the cross-section and then times it by its depth. So the area of the cross-section times by its depth. Let's look at the shape. I'm going to zoom in. Because it's a triangular prism, we know that the cross-section is the triangular part. So the cross-section of this prism is a triangle, because that's the same that side, and if you slice it, that triangle is going to remain. So area of a triangle, we need the base, which in this case is 3. We need the height, which in this case is 4. So the first thing I'm going to do is find the area of the triangle, which is 3 times 4, and then you half it. So 3 times 4 is 12, and half of 12 is 6. Now I'm going to find the volume. And volume is going to be 6, because that's our area, times by the depth. Now this is where it has the potential to get tricky, because do we pick that as the depth, or do we pick that as the depth? Now what you need to think with this net is that this part is going to be picked up and pretty much rolled over. So this side is, this side and this side are going to line up with that and that. So the depth that we're dealing with is actually that there, because this is where the triangle starts. It goes all the way through there and comes out at the end. And this is 2, 4, 6, 7 centimetres. So my volume is going to be 6 times 7, which equals 42 centimetres cubed. Now remember, I get 1 mark just for writing centimetres cubed anyway, so let's have a look where the other marks are. So you get 2 marks for managing to find the calculations correctly for the volume. It's 1 mark if you only got as far as finding the area. So you'd get 1 mark for that, but it's 2 mark if you've shown that you also need to multiply by 7. Then you get an accuracy mark for showing the 42 centimetres. So that's 3 marks. Then our third mark is this B1 mark for showing that you have the knowledge of the fact that volume is centimetres cubed. There's your 4 marks. Question 8 is a straight line graph question, and it looks quite complicated because they've got a fraction in it, but it's really no more complicated than if it was a whole number. So complete the table of values for y equals half of x plus 4. So y equals half of x, add 4. So here, because they've given us this one, I'm just going to check that I can do it correctly. Half of x, and that's x, so half of negative 2 is negative 1. Add 4 takes me to positive 3. Yeah, good. So here, half of negative 1 is negative a half. Add on 4 ends up giving me 3.5. Then this one, half of 1 is a half. Add on 4 is 4.5. So 4.5. And half of 2 is 1. Add on 4 is 5. So there's my table of values. I now need to plot them as coordinate points. And remember, coordinates are in the form of x, comma, y. So here I've got negative 2 across, 3 up. Negative 2, 3. Next I've got negative 1, 3.5. Negative 1, 3.5. Then I've got 0, 4. Then I've got 1, 4.5. Then I've got 2, 5. Then I'm going to take my ruler and I'm going to join them up. Now at this point, when I join them up, I'm just going to extend them off the graph because I may as well. That line's going to go on forever and it will always look the same. If I had realised when drawing this that I had a point down here, I know that I've made a mistake on that point. Okay, if the majority are all on a straight line and there's one that's not, then please recalculate it and write the correct answer back in here from the graph. Okay. Part C. On the grid, draw the line that is perpendicular to y equals half x plus 4. So that's the same line that they were talking about in the last part. And this passes through the point with the coordinates 0, 4. Then part 2 is they want you to find the equation of the line. I'm not going to answer this as 2 separate parts. I'm going to answer it as 1 separate part. First thing I have to understand is what does perpendicular mean. So perpendicular is when the lines cross at 90 degrees. So it's the opposite of what parallel is. Parallel lines keep going forever and never touch. Like this. Perpendicular lines cross exactly at 90 degrees. Alright, so that's what perpendicular is. However, when we're dealing with perpendicular and equations of lines and straight line graphs, what we're looking for is the reciprocal value of the gradient. Now straight lines are always written in the form of y equals mx plus c, where m is the gradient and c is the x. No, it's not. It's the y-axis intercept. So that's always your gradient. That's always where it hits the y-axis. Now, if the gradient of my original question was half of x, I need to find the reciprocal of that. So the gradient of my line is going to be the, well, let's write it out here. You don't have to though in your exam. Reciprocal of a half means that you just flip the fraction. So it would become 2 over 1, which actually equals 2. The thing is, our previous line that we drew had a positive gradient. It was going up. If we draw a line perpendicular, we know it's going to have to go downhill. So that's a negative 2. It's also a part over here, finding the reciprocal. When you find the reciprocal, it becomes a negative, okay? And if it's a whole number, it's a slightly different story. You do negative 1 over the gradient. And that was in the previous video paper, so go back and look if you need to. So now I found the gradient is negative 2x. I can write the equation of my new line. Y equals negative 2x. And because it tells me it cuts through the point of 0, 4, and remember coordinates are written in the form of x, y, it means that my y-axis is 4. So it's going to be negative 2 plus 4. Now that's enough there to give me 2 marks. However, in order to get the 3rd mark, I still need to plot the line. Now, if I needed to, I could generate a table of values from that. But let's look at the line. Now they told me my new line crosses through the point 40. So it's going to cut through that point. And it needs to be perpendicular. But it needs to be quite specific. Okay, if you look at this line, our gradient was across 2, up 1, across 2, up 1. We need to do the opposite for this. And the opposite for this is going to be across 2, down 1, across 2, down 1. Now I've got 2 or well, even 3 points on that line. I can draw it in. And look at that. That doesn't look perpendicular, does it? The reason it doesn't look perpendicular is because it's not. The opposite of going across 2, up 1 is not across 2, down 1. Now the whole reason that doesn't work out is because the examiners have been a little bit sneaky with the axis that we're given. Keep in mind that the gradient of the blue line, the original line, was a half. Now the gradient of my new line is -2, so it's going to have to be different to this. Now remembering that the gradient, and I say remembering from the last paper, gradient is the rise over the run, so the change in the y over the change in x. It means in order to get a gradient of -2, I need to come across 1, but 1 is actually 2 squares. So I'm coming across 2 squares, and then I need to come down 2 because it's got a gradient of -2. So that would be, you might be thinking, oh well that's down 2, but that's only coming down 1. We need to come down 2. So that's actually my next point. So I go across 1 whole 1 and I come down 2 whole 1s. Now I can draw that line in. And you can see that that looks a million times better with regards to being perpendicular to the blue line. So that does look like a 90-degree angle. So it was worth having a go because I bet most of you put this line in. It was worth having a go at that, but it's not correct. The correct line is the green one. Okay. Question 9 is a distance time graph question, and it's also a bit of a trick in it, as we'll see when we read down. So you've got to be observant when you're looking at these types of questions. So Lisa cycles to work. The travel graph shows information about her journey on Tuesday. So this line here is Lisa's journey to work when she cycles on Tuesday. Martin also cycles to work. On Tuesday, so the same day as Lisa, on Tuesday his average speed was 16 kilometers per hour. Who has the greater average speed, Lisa or Martin? You must show all your work in. Now I'm comparing two things here. I'm comparing Lisa and Martin. Because of that, I'm going to have this for Lisa and this for Martin. So I'm going to deal with Lisa's calculations here, Martin's over here. Because it's asking who was the greater average speed, that means I'm going to have to put a sentence at the end because it wants me to be specific about my answer. So let's look at Martin first of all. On Tuesday, his average speed was 16 kilometers per hour. So in 1 hour, Martin covers 16 kilometers. Brilliant. Let's find now in 1 hour how far Lisa travels. So Lisa, 1 hour equals, let's have a look at our graph. The graph doesn't go up to an hour. However, this is not the end of the world. What I can do is realise that it does have 30 minutes on there, and an hour is 60 minutes. So if I read the value for 30 minutes, that ends up giving me 4.5 miles. And this is where the trick comes in. So let's go down to Lisa. I haven't got her 1 hour thing, 1 hour speed. Oh God, 1 hour distance. But what I do have is her 30 minutes. And her 30 minutes is 4.5 miles. So here's the trick. We've got Lisa in miles and Martin in kilometres. First thing I'm going to do is get them both anyway out of an hour. So in order to get Lisa from half an hour and 4.5 miles to a full hour, I can just double it. So in 1 hour, Lisa travels 9 miles. Let's now convert Martin's kilometres to miles. Now the rule is 8 kilometres is 5 miles. So if it's 16 kilometres, what I can do is bring that down by dividing it by 8. That tells me how many lots of kilometres there are in 16, and that is 2. So there's 2 lots of 8 in 16. What I can do then is say, well, if there's those 2 parts, I need to multiply them by the 5 miles. So I divided by the 8 kilometres, and then I times by the 5 miles, and that's given me 10 miles. So in 1 hour Martin cycles 10 miles, and in 1 hour Lisa cycles 9 miles. Therefore I can see that Martin goes further in 1 hour. So I'm going to make my conclusion now that Martin is faster because he travels 10 miles in 1 hour and Lisa only travels 9 miles in an hour. So how are the 4 marks allocated for this question? Well, you get 1 mark for managing to get, let's mark this in green, I get 1 mark for managing to get the times to an equal number. So by getting them both to 1 hour, I'm showing that I know that they both need to be out of the same amount of time to compare. I also get a mark for a correct conversion from kilometres to miles. Now you might have done that conversion over here and had the answer in kilometres. That's fine also. So you get 1 mark for converting the time to a comparable amount. You get another mark for changing between metric and imperial. You get another mark for working out Lisa's speed in miles per hour. And you get the final 4th conclusion mark for making your statement based on that comparison. Question 10 is a ratio question, but it's not a straightforward ratio question. It does have potential to get you a little bit knotted up. So you've got to be careful about how we set this out. Mrs. Jennings shares £770 between her 2 sons, Pete and Tim. First of all, I'm going to write this out. 770, and it's going to go between Pete and Tim. She shares the money in the ratio of her son's age. So this is a ratio question. That means it's going to be Pete and Tim in ratio. So the combined age of her 2 sons is 66 years. Pete is 6 years younger than Tim. Alright. Let's work this out then. So I'm dealing with, can forget about the amount of money for now, let's look at the ratio. I'm dealing with Pete to Tim. Now I know that together their ages are going to add up to 66. Now I need an age for Pete and an age for Tim. But however old they are, Pete is 6 years younger. So I've got to try and keep that in mind. Now, I'm going to approach this from a logical point of view. You can go crazy with trials and errors, you know, well, if, you know, Tim is 40, then Pete is 34, so together they'd be, oh no, 74, that's too much. I'm going to say, well, their total age is 66, and there's 2 of them. So I'm just going to start by working out, if they were the same age, how old would they be? Now, they'd be 33 years. I know they're not both 33, because Pete is 6 years younger. Now, I don't take the 6 years off that. I consider the fact that, what would it be, and I will do a couple of trials here, what will it be if I have 6 younger years than Tim? Sorry, I don't know why I'm stuttering over this. So I'm going to take a guess at, let's just take the 6 off, right? Let's just say that Tim is 33, and so Pete is going to be 3 less than that, so he's going to be 27. 27 and 33, they add up to give me 50, 60. So that's not good enough. So in order to be clever about this, you need to think they can't both be 33. But if I take some away from Pete, they're going to get added on to Tim. So I don't need to take 6 off Pete. I only need to take 3 off Pete, because then that 3 are going to be added to Tim, which would end up putting Pete at 30 and Tim at 36. Now 30 and 36 go together to give you the 66 you wanted, and they also have a difference of 6. So they're the ages. I'm going to come over here and I'm going to write that as a ratio. Pete to Tim is 30 to 36. Now I can simplify that ratio, 30 to 36, because I can see 6 goes into both those numbers, and 6 goes into 30 5 times, and 6 goes into 36 6 times. So Pete and Tim are in the ratio of either 30 to 36 or 5 to 6. It doesn't really matter. Now it's just your basic sharing into a ratio question. I've got 11 parts in total, and into that 11 parts I've got to share £770. So it is 770 divided by the 11 parts equals 70, and that's money, so it's £70 per 1 part. £70 per 1 part. Now let's think of Pete again. Pete had 5 parts, so Pete has got 5 lots of £70. So Pete has £350. Now Tim has 6 lots of £70, so he has £420. If you don't know how these calculations are done so quickly, it's because it's 6 times 70, so you can do 6 times 7 is 42, and then put the 0 on the end if necessary, but you need to learn some multiplication tricks if you don't know how to do things like this. So that's my question answered. Before I move on, I'm going to just check that they do add together to give me the 770 I wanted, and yes they do, so I must have done it correct. With regards to how are the marks allocated, you get 1 mark for stating the ratio as 30 to 36. You get another mark for, where would that other mark come from? You get another mark here for doing the division of the ratio. You get a mark here for showing that you've multiplied the ratios up. You get an answer mark here for getting both of those correct. And then you get the final mark for